Okay, no more notes. Yay, just homeworks now. 7H, homework. Today's date is Thursday, April 5th. If you were absent Wednesday, make sure you have the sub give you the notes and homework from yesterday. Watch the video. There's one video on both of them. First the notes, then the homework. No need to turn anything in, but you can use all this stuff for your test on next Wednesday, so make sure you have everything. Okay, this is just a homework. All right, it says directions. Fill in the blanks in each section below. Match the problems to the correct directions and place one in each open box and solve each problem. So the first one, there's 4 boxes. Okay, there's 4 boxes. Do you guys see that? 1, 2, 3, 4. It doesn't matter what order. It says log on one side. So find all the ones that have a log on one side. So like this one doesn't even have a log, so it's not that one. This one has a log on one side. There's no log over here. So this one we can write here. Let's keep going. This one has 3 logs. There's logs on every side, so this is not the case. No logs. There's a log on one side here, so let's write that here. It's a log on one side. No log, no log, no log, no log, 2 logs, log, log, log. So here's one, log base 4x equals -2. So there's those. So you have 3. There's one more that has logs on one side. So there is no other ones that just has a single log. By the way, I'm going to cross these out. These are the ones we've used so far. We've used these. I'm going to cross the ones out that I've already wrote. There's one more that just has logs on one side. Like it's not this one because this has logs on both sides. Find the ones that have logs. This one has logs on one side. This one has logs on both sides. So which one should I pick? I'm going to pick this top one. Log base 2 6 plus log base 2 x minus 2 equals 3. This has logs on the same side. But on this one, we're going to have to condense. Let's just do that right now. We can condense this to 6 times x minus 2. And now it has a single log on the left-hand side. So all of these are logs on one side. And what do we do if we have a log on one side? We swoop it. We're doing some swooping. Okay, here we go. What's the base? 10. So it's 10 squared equals 3x plus 25. 10 squared is 100. Subtract 25. Divide by 3. And x is 25. Done. Okay, here we go. Next problem. Swoop. Starting with your base. Swoop. 2 to the 5th equals 4x. 2 to the 5th is 32. Divide by 4. X is 8. Swoop. 4 to the -2 equals x. 4 to the -2 is really 1 over 4 squared, which is 1/16. I don't care if you give me 1/16 or if you type in your calculator 4 raised to the -2 and get a fraction, a decimal, 0.0625. I would also accept 0.0625 or 1/16. We've already condensed, not this fourth one, we've already condensed a single log. So we're going to swoop. 2 to the 3rd equals 6x minus 12. 2 to the 3rd is 8. Now we're solving for x, so add 12. Divide by 6. And what is 20 divided by 6? 3 1/3. If you press math, enter, enter, it's 10/3. So we'll go 10/3 or 3.3 with a bar. All right, so we got 4 of them out of the way. 1 log on the left, 1 log on the right. Looks like there's only 2 of these, okay? That means you have logs on both sides. So that's this one. So let's rewrite that. Log base 3 of x minus log base 3 of 4 equals 2 log base 3 of 3. Logs on both sides. So let's cross that out. And then the other one is over here. See how you have log on both sides? Oops. See you have log on both sides? So we already used this one. So let's use that one. Okay, so what do you do if you have a log on each side? You drop the logs, but you cannot drop the logs unless you have one log on the left side and one log on the right side. Look at this problem. It doesn't have one. It has 3 logs. Let's condense first. This is log base 3 of x divided by 4. Also, see this 2? You can't drop them if there's a number out front. So you should make that a 3 squared. See how there's nothing out front, nothing out front? Single logs, this is when you drop your logs. Not until there's a single log on both sides. So you have x over 4 equals 9. We're going to put 9 over 1, and we're going to cross multiply. So it's x equals 36. Now this one does have, see this one? Log base 2, log base 2. There's nothing out front, nothing out front. There's a single log. We can just go ahead and drop right from the start on this one. So you have 2x minus 1 equals x plus 2. Let's subtract x to the other side. Add 1, and x is 3. Boom. Done. Same base of the exponents. Same base of the exponents. Same base of the exponents. So there's going to be, the only thing that's left, let's look at these. So all the ones with logs are gone. Anything that had a log in it's gone. So what's left is all exponents. You either can or you can't put them in the same base. Can you put these in the same base? These are the same base. So we're going to write that one in this box. That's good. All right, so that one's done. Same base. Can I write 7 and 25 in the same base? No. Don't write that here. Can you write 4 and 7 in the same base? No. Can you write 2 and 64 in the same base? Yes, I can. Look on the board. Look on that whiteboard in the front of the room. What is 2 to the 4th? 64 is really 2 to the 6. So I can put these in the same base. So that's considered same base of the exponents. You cannot put 3 and 36 in the same base. You cannot put 6 and 215 in the same base. So the only 2 that we could do are the 2 that I chose. Okay? So what do you do if you have the same base of the exponents? You drop the base. So we're just dropping the 5s. So we have 3 minus 2x equals negative x. My God, you can't see this, sorry. Drop the base, set the exponents equal. So I'm going to add 2x to the side and get 3 equals x. And that's it. Done. This one, I already switched 64 to 2 to the 6. So we can drop our bases now. 3x plus 2 equals 6. Subtract 2. 3x equals 4. And x is 4/3. Done. So that means the last 4 go in here. So we have 7, x minus 3 equals 25. That one's done. We have 4x to the 7. That one's done. We have 3x to the 36 here. That one's done. And we have 6x, let's see, it's 3x plus 1 equals 215. And that one's done. And that's all of them. So that's our last 4. If x is in the exponent and you can't put them in the same base, then you take the log of each side. Okay? Common log. So let's do it. Log of the left side, log of the right side. After you do that, you're going to release the exponent, x minus 3, which by the way is a binomial, so keep it grouped, out front. And we're solving for x, so the first thing I would want to do is get rid of this log. Just remember, log of 7 is just a decimal. Let's just get rid of that. X minus 3 equals log 25, parenthesis, divided by log 7, parenthesis. That's about 1.6542. Add 3 to both sides, which I'll just do that right now in the calculator. And your final answer is 4.6542. That's it. 4x to the 7. Let's take the log of each side because I can't write 4 and 7 in the same base. Release the x out front. Divide by log 4. .4037. Next problem. Take the log of each side. What am I going to do with this x, everybody? Where's it going? It's going out front. X log 3 equals log 36. Let's divide by log 3. Now remember, this is not log 12. Log 36 divided by log 3 is not log 12. Don't remember that. Don't make that mistake. Divided by log 3 is 3.2619. Boom. And then this problem is just a little bit harder. Take the log of each side. And the reason it's a little bit harder is because that's a binomial. Just a little bit more solving at the end. Okay, so you have this. Let's release this out front. Keep it grouped together in parentheses. Let's divide both sides by log 6. So you got log 215 divided by log 6, which is about 2.9974 equals 3x plus 1. So we're solving for x, so subtract 1. Then divide by 3. So we subtracted 1. Then we divided by 3. So it's about 0.6658 for your answer. True or false? It's natural log of 12 divided by natural log of 12, natural log of 2. It is false because it's really natural log of 24 minus 12. You would subtract them. You would condense to 1 and you would subtract. Actually, I'm not even sure that's right. You can punch this in the calculator. Watch. Natural log of 24 divided by natural log of 12 equals this. And then natural log of 2 is this. They're not the same thing. So are these true? No. False. Is 3 log 3 base 3 of x equal log base 3 of 27? So what did they do here? It looks like they divided both sides by 3. If you want to know if that's true, it just isn't. This 3 goes to this exponent right here. It doesn't divide by 3 to the other side, so this is a false. Is 3 to the negative 2 the same thing as negative 9? No. 3 to the negative 2 is actually 1 over 3 squared, which is 1/9, not negative 9, so that's false. These are all common mistakes people make with logarithms. If you had this problem right here, it looks like they tried to divide everything by 6. Can you do that? No. You would actually expand this. It'd be log base 2 of 6 plus log base 2 of x plus 2. You cannot just divide by 6. They're not regular problems. Logarithms have their own special properties. You just can't divide by 6. Is 2 to the negative third 1/8? Yes, it is, because this is 1 over 2 to the third, which is 1/8. First one that's true. Is this the same thing? Let's see. So you have two factors. Did they expand it? It looks like they dropped the logs. Ooh. I'm going to say this is right. You can drop the logs here. Yes. And then this one, basically the 2 would have to come out front, be 2 natural log of e. Natural log of e is 1, so this side is 2. It is not equal to 2e, so this is false. And that's your homework.